All right, we're in this chapter and we're talking about writing linear functions. And in order to do that, we'll utilize some tools. One of them is the slope-intercept form. Another is point-slope. We will use our slope formula to calculate slope, y2 minus y1 over x2 minus x1. We'll do all those, and then we will see about, have a little quick discussion on parallel and perpendicular lines. So let's look at this first one, which is slope-intercept form. Now, slope-intercept form is written in the form of y equals mx plus b, where m is the slope and b is the y-intercept. Y-intercept. All right, so up here we're given some facts. We're given that the slope of the line is 1.5, and we're given a coordinate, which happens to be where x is equal to 0 and y is equal to 5. Now, if we were to calculate, if you go back and think about when we were calculating or figuring y-intercepts, when we were figuring y-intercepts, we would set x equal to 0. So in other words, when x is 0, we would find the y-intercept by plugging 0 in for x in the equation. Well, if we're given a coordinate point, a point, and we have x is equal to 0, well, in this case 0, 5, that tells us that the y-intercept is at 5. And so this is just really just a matter of substitution. I substitute in 1.5 for m, right there. And I substitute in 5 for b, which is the y-intercept, and it's just simply y equals 1.5x plus 5. Now, what if we're given 2 points, and I want to put it in slope-intercept form? Well, remember now, I've got to, if you remember what our slope formula is, y2 minus y1 over x2 minus x1, and that's going to be the first step in my process. So we can see here I've got a point minus 2, 3, and another one coordinate 0, 1. And yeah, so I got 1, which is my y2, minus 3, which is my y1, over 0, which is my x2, minus 2, which is my x1. Well, when I figure this out, 1 minus 3 is going to give me minus 2, and 0 plus 2, because minus minus is a plus, remember. So it's going to give me minus 2 over 2, which is going to equal minus 1. And now I'm just going to put this in slope-intercept form. So my, I should have a minus right there. Wrote that wrong on the board. So y equals, let me rewrite that, y equals minus x plus 1. Now, where did I get the 1 from? Well, in this coordinate pair right here, I see that x is equal to 0, which must mean that that 1 is the y-intercept. And so I got y equals minus x plus 1. All right, so now we're going to write an equation in point-slope form. Now, point-slope form is this right here. Y minus y1 equals m, which of course is the slope, times x minus x1. And so in this problem right here, and I think I've got, looks like I probably got 3 of these on this slide. Here I'm given a coordinate point of 2, 3, and I'm given the slope of 1/2. So I'm just going to substitute in. So I've got y minus 3. I'm getting that 3 from this y1 right here, point that I know about. Y minus 3 equals 1/2, which is my slope that I was given, times x minus 2. Well, now it's y minus 3 equals 1/2 x, and I distributed the 1/2 times the minus 2, which gave me minus 1 right there. And now I'm going to add 3 to both sides to isolate the y. Y equals 1/2 x plus 2. And so got positive 3 minus 1 gives me plus 2. And what does that look like right there? So I went from point slope to slope intercept. Okay, how about that? All right, here's another one here. I got a point here. It's -2, -1. Slope is -3. So I substitute in. I got y minus -1. I'm getting that -1 from right here. That's my y coordinate. Y1 coordinate coming up here. Y minus -1. When I say coming up here, I mean right here. -3, substituting in the slope for m, parentheses, x minus -2. So there's my -2 that I substitute in for this part of the point slope equation. And so now I've got y minus -1, well, that's y plus 1, equals -3x. And distributing that -3 to this -2, which is really a +2, -3 times +2 gives me -6. And I subtract 1 from both sides, and I'm left with y equals -3x minus 7. Now, what about if all I'm given is 2 points and none of them tell me what the y-intercept is going to be? Well, again, now remember, when I'm calculating slope, is y2 minus y1 over x2 minus x1. And so I'm going to have to manually calculate the slope. And so I got -4 minus -9 over 2 minus 4. Well, -4 minus minus, that's +9. -4 plus 9 gives me 5. And 2 minus 4 is going to give me -2. So I got 5 over -2. And I'm just going to kind of rewrite that because I want to put that negative sign, that minus sign, more in the central part of that fraction. I didn't really have to do that, but it just looks better to my eye. Okay, now right here, I'm going to calculate, end up with my linear equation, linear function equation. So I've got, and in order to do that, I can pick either one of these two coordinates that I want to. It doesn't really matter which one I pick. I just happen to pick this one right here. And so I got y minus -4, pulling that -4 from right there, equals -5 over 2, which is what I calculated the slope to be, times x minus 2. So we got y plus 4. Well, -4 gives me y plus 4 equals -5 over 2x. And when I distribute the -5 halves times the -2, well, the 2's are actually going to cancel. And so I've got -5 times -1 gives me +5. All right, now I'm going to subtract 4 from both sides. And so I end up with, finally here, y equals -5 over 2x plus 1. Let's look at one last one here for this where we're given 2 points. Here I'm given two coordinates, -9 and 11, and -6, -1. I'm going to plug it into my slope formula right here. So I got -1 minus 11 over -6 minus -9, or a +9. And -1 minus 11 is -12, and -6 plus 9 gives me 3. And so I got -12 over 3, which I can reduce here to -4. Now, same thing I'm going to do. I'm going to go back to the point slope formula or equation, point slope equation, which is what I'm employing right here. And again, I decided I was going to pick that coordinate. No special reason. I just kind of figured I like the smaller numbers. So y minus -1 equals -4 times x minus -6. So I got y plus 1 equals -4, parentheses, x plus 6. That's going to turn to a +6. Minus is a positive. Y plus 1 equals -4x. Well, even though this was a +6, I'm still distributing -4 to it. So I'm still multiplying a negative now times a positive. So I end up with -24. Y plus 1 equals -4x minus 24. I'm going to subtract 1 from both sides. And my linear function equation is y equals -4x minus 25. Now, here's a fact. If two lines are parallel, they will have the same slope. So if I'm given some information and I'm told what the slope is, and I'm asked to write an equation for a line that is parallel to another line that has this slope, but the line that I'm writing the equation for has this point, 3, 7. So this is the coordinate of the line I'm writing the equation for. So again, let's think about what point slope is. Y minus y1 equals m slope x minus x1. And that's what I'm using right here. So I got y minus 7 equals, and I'm using this slope. It's parallel. It's going to have the same slope. That's all I need to know. I know the slope of one line. You're telling me you want me to write an equation for a line parallel to that. I'm going to use the exact same slope. So 3/4 times x minus 3. So I got y minus 7 equals 3/4 x minus, when I distribute the 3/4 to the minus 3, I'm going to end up with minus 9/4. Now I'm going to add 7 to both sides. So I got y equals 3/4 x minus 9/4 plus 7. Well, now in order to add these two together, I've got to get them to a common denominator, which I'm going to do as 4, which means I'm going to multiply that 7 by 4/4. 4/4 is just 1. If I multiply those two together, I haven't changed the value. So let's see, we got y equals 3/4 x minus 9/4, and when I convert that 7 into fourths, it's going to be 28/4. And to finish this off, I got y equals 3/4 x, and so I got minus 9 plus 28, minus 9 plus 28 gives me positive 19. So y equals 3/4 x plus 19/4, and that is the equation. That's going back to slope-intercept, y equals mx plus b. And that's the equation of a line parallel to another line that has a slope of 3/4. Now, here's another thing about lines. If two lines are perpendicular to each other, say they're like this, that's perpendicular, or that's roughly perpendicular. If I were to take the slope of two perpendicular lines, multiply them together, then my product is going to be minus 1. So if I had a slope of a line, let's say that was minus 2, well, a line perpendicular to it would be 1/2. And if I multiply, I mean, I shouldn't use x probably, but anyway, minus 2 times 1/2, well, that's going to give me minus 1. Or let's say I've got a slope of a line that is 3/4. Well, for a line that's perpendicular to it, its slope would be minus 4/3. And if I were to multiply those two numbers together, well, I'm going to get minus 1, which means that they are perpendicular lines. So in this problem here, I am given that the slope of the line is minus 5/3. And I'm asked to write a line that is perpendicular to that also travels through the points minus 9, minus 3. So again, we're going to employ the same thing, point slope. Start with point slope. And so I've got y minus minus 3, get that minus 3 from right there, equals 3/5. So what I did is I've taken the reciprocal of minus 5/3 and changed it from a negative to a positive. So minus 5/3, well, a line perpendicular to that is going to have a slope of 3/5. Just substitute that in. So y minus minus 3 equals 3/5, 3/5 times x minus minus 9, or positive 9. So I got y plus 3 equals 3/5 x plus 27/5. When I distribute the 3/5 to the positive 9, I'm going to get 27/5. I'm going to subtract 3 from both sides right here, so I'm left with y equals 3/5 x plus 27/5 minus 3. Well, just like when I did just a few moments ago, I've got to convert this minus 3, give it a common denominator with my other fraction here, which is 5, and I can do that by minus 3. If I multiply that minus 3 times 5/5, well, I'm going to end up with minus 15/5. So y equals 3/5 x plus 27/5 minus 15/5. And my final answer for a line perpendicular to another line that has a slope of minus 5/3, and the line that I'm asked to write is traveling through points minus 9, minus 3, well, the equation for that line is going to be y equals 3/5 x plus 12/5. Can't get much better than that.